Chapter 2, Lesson 4, Newton's third law of motion. Opposite forces. Have you ever been on inline skates and pushed against the wall? When you pushed against the wall, like the boy is doing in figure 20, you started to move away from it. What forces cause you to move? You may think the forces of the muscle in your hands moved you away from the wall, but think about the direction of your movement. It might be hard to imagine when you pushed against the wall pushed back in the opposite direction. The push of the wall caused you to accelerate away from the wall. When an object applies force on another object, the second object applies a force for the same strength on the first object, but the force is in opposite direction. Newton's third law of motion. Newton's first two laws of motion describe the effects of balanced and unbalanced forces on one object. Newton's third law relates forces between two objects. According to Newton's third law of motion, when one object exerts a force on a second object, the second object exerts a force on a second object. The second object exerts an equal force in the opposite direction on the first object. An example of forces described by Newton's third law is shown in figure 21. When the gymnast pushes against the bolt pushes back against the gymnast. Notice the lengths of the forces arrows are the same, but the directions are opposite. Force pairs. The force pairs described by Newton's third law depend on each other. A force pair is the forces two objects apply to each other. Recall that you can add forces to calculate the net force if the forces of a force pair always act in opposite directions and are always the same strength. Why don't they cancel each other? The object is that each force acts on a different object, and force of the boat acts on the girl's feet. The forces do not result in a net force of 0 because they act on different objects. Adding forces can also result in a net force of 0 if the forces act on the same object. Action and reaction. In a force pair, one force is called the action force. The other force is called the reaction force. The girl in figure 22 applies force in the force that the boat applies to the girl. For every action force, there is a reaction force that is equal in strength but opposite in direction. Using Newton's third law of motion. When you push against an object, the force you apply is called the action force. The object then pushes back against you. The force applied by an object is called the reaction force according to Newton's second law of motion. When the reaction force results in an unbalanced force, there is a net force and the object accelerates. As shown in figure 23, Newton's third law explains how you can swim and jump. It also explains how rockets can be launched into space. Momentum. Because action and reaction forces do not cancel each other, they can change the motion of objects. A useful way to describe changes in velocity is by describing momentum. Momentum is a measure of how hard it is to stop a moving object. It is the product of an object mass and velocity. An object momentum is the same direction as its Lose their velocities and they lose momentum. Types of collisions. Objects collide with each other in different ways. When colliding objects bounce off each other, it is an elastic collision. If objects collide and stick together, such as when one football player tackles another, the collision is inelastic. No matter the type of collision, the total momentum will be the same before and after the collision.